I'm Terry Klinker. We're going to finish our discussion of decision analysis in this section. We've already discussed how to set up a decision. We've discussed several different techniques. We went through minimax, maxi-min, minimax regret. We went through expected monetary value. We did all those in the table. Then we turned around and solved it graphically. I'm going to show you another way to use it called decision trees today. Now decision trees are, we're going to use the exact same problem. We're still going to be looking at solving for our condos, all right? But a decision tree is kind of a picture. It puts a graph together that is a little bit easier to understand for some people. So the first thing you have to understand is we have two types of nodes in our decision tree. The first node is a square. As square, we make decisions. No calculations are done at a square. All right. We also have circles. Circles are where we calculate expected monetary value. This is where we do calculations. All right. Two important things that we need to remember about decision trees. You have to build the entire tree before you can solve it. So we build it from left to right. Once we've got it built, then we go through and we solve for it from right to left. All right? If that's throwing you off, I'll put right over here and tell you we're going backwards through it. You have to solve from right to left. So let's go back through. Think about our 4 steps that we built into making our decision. The first one was to find the problem. Our problem was we need to make a decision. All right, we're making a decision. It's a square. Our decision is what type of condos are we going to build? Small, medium, large, or no investment whatsoever. Once you've got the decision, now what are your options here? I have 4 options. I can build small condos. I can invest in medium-sized condos. I can invest in large condos. And of course, I can invest in no condos whatsoever. I can have no investment whatsoever. Now, with each decision, there are states of nature. We talked about that earlier. In this case, we had 2 states of nature. We could have strong demand for our condos, or we could have weak demand. So small, I've got a state of nature. My circle is also considered a state of nature node. In this case, I could have strong demand for condos, or I could have weak demand. For mediums, same thing, strong and weak. Large, strong, and weak. Now you'll notice I didn't put a strong or weak with the no investment. That's because it doesn't really matter. If I don't make any investment whatsoever, if I choose not to invest in any condos whatsoever, I know what the end result will be. It will be worth $0 no matter what the state of nature is. Once we've gotten to this part, now we need to put the values at the end. If I invest in small condos and I have strong demand, it's going to be worth $7 million. If we have weak demand, it'll be worth $8 million. Strong demand with medium, $14 million. Weak demand, $5 million. Strong demand, $20 million. Weak demand, I lose $9 million. We have now built the entire tree. Other trees could be more complex. As I told you at the beginning, I was doing this simply so that it made it easy for you to follow along with the calculations. We could have ones where it extends beyond here, where there are different options depending on which option you take. There are different states of nature. All right, but I kept this simple. Now we're going to solve this from right to left. To solve it, we need to know one thing, really. What is the probability of strong demand? Well, We're going to use this as the probability of strong demand is 0.35. 35% probability of strong demand. That means we need to figure out what is the expected monetary value here. The easiest way to do that is to label these. I would call this A, B, and C, and I'll call this D. So your nodes will need labels of some type. My expected monetary value here at A is going to be, I have a 35% chance of strong demand. So it's going to be $7 million times 0.35 plus $8 million times 1 minus 0.35, or 0.65. When you go through the math on this, you'll find out that this is worth $7.65 million. That means my value here, go ahead and put that in, 7.65. My expected monetary value at B is going to be $14 million. I have a 35% chance of getting 14 million. I have a 65% chance of getting 5 million. Do the math for that, and we come up with $8.15 million. So the value here is 8.15. Expected monetary value here at C is going to be 20 million times that 35% probability, plus I could lose 9 million, and I have a 65% chance of losing 9 million. When I do the math for that, I end up with an expected value of $1.15 million at C. I've now figured out, I'm solving it from right to left. I've got my number here, my number here, my number here. I have the number for this last one coming in. Now I can make a decision. At my decision point, all I do is figure out what the best option is. So I look at it here. A is, if I decide to go A, I get 7.65 million. B, 8.15 million. C, 1.15 million. And if I take this option, I get no money. Since we're looking at expected return, that's a positive number. It's a positive thing. The bigger the number, the better. I picked the biggest of these. The biggest is 8.15 million. At this point, I would choose option B, and the value here is $8.15 million. Couple things to notice here. I didn't do any calculations at the square. I just took the best option. Also, at 0.35, I would choose to invest in medium-sized condominiums. Let's go back to our graph. Let's go back to everything we did before. It says that if P is between 30% and 70%, we would choose medium condos. Notice that every tool that I did gives me, whether I solved it by hand with an indifference table, or with a graph, or with a decision tree, I always get the same answer. So even though I'm giving you different tools, they are consistent with each other. If you use different tools and you get different answers, you have a problem. That concludes our discussion of decision analysis.